So in this video, we're going to go through some more examples of solving simultaneous equations, where one of the equations is of the form x equals ay plus b, okay, or x equals a minus by, if you like. And then the other equation this time is y is equal to mx plus c, okay, or y equals c plus mx, if you like. So with these, because one of them is x equals then an expression for y, and the other is y equals some expression for x, in actual fact, it doesn't matter which way round you substitute the equations. Well, it really just allows you easily to substitute one into the other, okay? And it doesn't matter which way round you do it. So with the first one, we've got x is equal to y plus 10, and y is equal to 2x plus 20. So you could go, well, if I've got x equals y plus 10, then I can replace the x with y plus 10 and get y is equal to two lots of, y plus 10, close bracket, plus 20. So I've substituted that one into there. Or you could have substituted that one into there and got x is equal to y, which is 2x plus 20, plus 10. Okay? So if we go through this way first, expand the brackets out, 2y plus 20 plus 20. We can subtract 2y from both sides and we'll have 20 plus 20, which is 40. And then multiply through by minus 1. So y is equal to minus 40. And then if you want the x value, substitute it into this one to get x is equal to minus 40 plus 10, which is minus 30. And so the two lines intersect when x is minus 30 and y is minus 40. Okay? Alternatively, you've substituted that one into this equation here to get this. And if we subtract 2x from both sides first, because there's no brackets to expand. So subtracting 2x from both sides, got minus x. 20 plus 10 is 30. Multiply through by minus 1, we get x is minus 30. And then, to work out the y value, you would substitute that into this one, because that's y equals. So y is equal to two lots of minus 30 plus 20 is minus 60 plus 20, which is minus 40. So the two lines intersect at minus 30 minus 40, which is precisely the answer that we got before. Okay? So it doesn't matter which way round you substitute the equations in this one. I think what I'll do with each of these examples is go through both, just in case, if you've paused the video and you've had a go and you've substituted all of the y's into the x's, then I'd like you to be able to see the method, okay? So we're going to have a go at each of these with both methods. So it'll take a little bit longer, but I think worth it. So x equals 5 take away y, and y is equal to 3x plus 2. So let's first of all substitute the first one into the second one. Okay, so that into there, we'll get y is equal to 3 lots of x, which is 5 take away y plus 2. Expand the bracket out, so we're going to get 15 take away 3y plus 2. Let's add 3y to both sides, and then we've got 15 plus 2, which is 17. So y is 17 quarters, dividing both sides by 4. So x is equal to 5 take away y. Now 5 is 20 quarters. So 20 quarters take away 17 quarters is 3 quarters. So the two lines intersect at 3 quarters, 17 quarters. Now, if you substituted that one into there, we're going to get x is equal to 5 take away y. So make sure that's in a bracket, otherwise you're going to forget subtracting the 2. okay? So that's 5 take away 3x take away 2. We'll add 3x to both sides. 5 take away 2 is 3. Divide both sides by 4, we get x is 3/4. Then we're going to substitute that into the second equation. So y is equal to 3 lots of 3/4 plus 2. So that's 9/4, and 2 is 8/4. So 9/4 plus 8/4 is 17/4. So the x coordinate is 3/4 and the y coordinate is 17/4. Okay? So that's number 2. Right, number 3, we have x is equal to 4y minus 1 and y is equal to 3/2 x take away 2. So, first of all, we'll substitute this one into that one. So y equals 3/2 of x, which is 4y minus 1, take away 2. So y equals, now 3/2 times 4 is 12/2, which is 6. 3/2 times minus 1, then we've got the take away 2. Now let's get rid of the fraction, so we'll multiply everything through by 2. Now you could have multiplied through by 2 at that stage if you prefer, and that would have saved you expanding out by 3/2. So multiply through by 2, we're going to get 2y equals 12y, take away 3, take away 4. So if we subtract 12y from both sides, so minus 10y, we've got minus 3, take away 4, which is minus 7. Divided through by minus 10, y is 7/10. So use that equation, x equals 4 lots of 7/10, take away 1. So that's 28/10, take away 10/10, which is 18/10. Divide top and bottom by 2, 9/5. So we're going to get 9/5, 7/10 as the point where the two lines intersect. So if we do it the other way around now, we're going to substitute that one into that one. We're going to get x is equal to 4 lots of 3/2 x take away 2, take away 1. So 4 lots of 3/2 is 12/2, which is 6. So 6x, 4 times minus 2 is minus 8, take away 1. So this way has ended up with no fractions to deal with here, okay, which is useful. Subtract 6x from both sides, so minus 5x is equal to minus 8 take away 1, which is minus 9. Divide through by minus 5, so x is 9/5. So if x is 9/5, I'll substitute that into the second equation to work out y. So 3/2 times 9/5 take away 2. Okay, now 3/2 times 9/5. 3 9s are 27. 2/5 is 10, 2 times 5 is 10. So if I get that in tenths, that's 20/10. So 27/10 take away 20/10 is 7/10. So the x is 9/5 and the y is 7/10. Okay, so that felt a little bit easier that way around. Okay. Right, that's number 3. Right, number 4, we have x equals 1/2 y minus 3, and y is equal to 1 take away 2/3 x. Okay, so let's substitute the first one into the second one first. Y equals 1 take away 2/3 of 1/2 y take away 3. So let's expand the bracket. So 1 take away. Now 2/3 times 1/2 is 2/6, which is 1/3. So 1/3 y. And then we've got 2/3 times 3. which is 6/3, which is 2. So plus 2. Now let's get rid of that fraction. So multiply everything through by 3. So 3y is 3, take away y plus 6. Add y to both sides. 3 plus 6 is 9. Divide through by 4, so y is 9/4. So now substitute into the first equation to work out x. X is 1/2 of 9/4 take away 3. So 1/2 times 9/4 is 9/8. Now 3 is 24/8. Now 24 take away 9 is 15, so it's minus 15/8. So the x value is minus 15/8 and the y value is 9/4. Okay, so let's now do this equation substituted to that one. So x is 1/2 of 1 take away 2/3 x take away 3. So we'll expand the bracket. So 1/2 take away. Now a half times 2/3 is 2/6, so 1/3. So minus 1/3 x, and then we've got the take away 3. Now we've got both a half and a third here. So you can either multiply through by 2 first, or multiply through by 3 first, or multiply through by 6, because 6 is 2/3, 2 times 3. And that will deal with both fractions at the same time. Let's do it stage by stage. We'll multiply through by 2 first. Then we'll multiply through by 3. Like so. We'll add the 2x to both sides. So 8x. 3 take away 18 is minus 15. So x is minus 15/8. Okay. Then I need to substitute that into this equation to work out y. So 1 take away 2/3 times minus 15/8. Not very pretty. Okay. Now, there are ways to simplify that before multiplying, but it's a little bit more fiddly. So, well, it's not that it's fiddly, it's just that I don't want to kind of like slow it down. So let's just multiply those two fractions. Multiply tops and multiply bottoms. So we're going to get 30 over 24. So we'll write the 1 as 24 over 24 plus 30 over 24. So that's 54 over 24. Now 54 and 24 are both divisible by 3. They're actually both divisible by 6. So if we divide top and bottom by 6, that's 9 over 4. So the x value is minus 15/8 and the y is 9/4. Okay? So through these examples, has there always been a method that's been easiest as to which one you should substitute to the other? I wouldn't say so. I would say with that example, I found this one easier than that one, personally. But with the previous example, I found that method easier than that one. So I don't think that there is just like one way to do it that is generally easier. But the key thing is showing you that it doesn't matter which method you use, either will get you to the correct result.